Hello students, good morning all. Today we'll discuss about the practical which is based on FSK modulation using XR2206 IC. So in this practical all of you are aware about FSK modulation. So here it will generate the two tone of the frequencies. One is for mark and second one is the space frequency. So mark frequency, which is nothing but the frequency generated with the help of logic 1. At that time you are connecting the input to the VCC, and space frequency is nothing but the frequency which is applied for logic 0. So there is two resistors are available in this circuit, R1 and R2, that are helpful to calculate the mark and space frequency. So to calculate the mark frequency, the formula is 1 upon R1 into C1. So R1 resistor is over here. Use this capacitor C1 to calculate the mark frequency. Second frequency is nothing but the space frequency. So you can calculate the space frequency as 1 upon R2 into C1. So use this R2 resistor, use this C1 capacitor to calculate the space frequency. So here initially we connect the circuit as we are connecting the VCC to the VCC. We are connecting the ground to the ground. Then here, once you are connecting the VCC and ground, here you have to check initially the output for logic 1 and logic 0, whatever the frequencies are generated over here, that you have to observe. So connect the CRO at the output. So positive is connected over here and ground is connected over here. So this one is CRO positive and this one is your CRO ground. Okay. Then connect this input pin initially to the VCC, that is nothing but with the help of this VCC you can obtain the logic 1 frequency. So this is your CRO. Check here the output. So this is your waveform which is generated for the logic 1 frequency. So here initially find out how much time you get. So for measuring the time, here adjust this waveform and measure the peak to peak distance, horizontal distance, to measure the period T. So here the peak to peak distance coming from this wave, suppose I have considered from this point. So here the wave is completed up to this point. So the total distance up to this peak is, start from this origin 0, one line is indicates as 0.2, so 0.2, 0.4, 0.6, 0.8 and 1, up to this is 1. So then this peak as 1.6. So 1.6 into this time per division knob is available on a 50 microsecond. So calculate this 1.6 into 50 microsecond, you get that period T, and after calculating the period T you get that frequency near about a 10 kilohertz. Near about a 10 kilohertz. Similarly, connect this input to the ground. Connect this input to the ground, you get the second frequency. You get the second frequency which is nothing but a logic 0 frequency, that is for space frequency. So again measure the peak to peak distance, you get the T, that is period T, and after getting the period T calculate the frequency. So you get that frequency near about 1 kilohertz. Okay. Then after taking this two frequency, measuring that two frequency, calculate, you have to see the final response coming from the FSK modulation. So to see the final response, connect the function generator, add the input. Just a minute. So here I have connected the function generator positive to the positive. Then I have connected the second terminal, that is the ground terminal. So at the input side you are applying the TTL input. So this is your TTL input. So after connecting the TTL input, here you have adjusted the frequency as up to the 90 Hz. So for up to the 90 Hz you get the